Hello children. Well children, in the previous in the previous session, we have learned that the earth is surrounded by the atmosphere. No. So this is the atmosphere which is of different layers. Okay, this is our planet earth. Okay, and it is surrounded with the atmosphere. And it has got 5 layers. No, this is troposphere, stratosphere, mesosphere, thermosphere, exosphere. No, and these layers of atmosphere is not to scale, in the sense we cannot measure it. We cannot measure it. Okay, so not to scale in the sense which is not able to measured. Okay, so we have learned that about troposphere, about stratosphere and mesosphere, thermosphere, exosphere, and we also learnt about the ozone layer. No, ozone layer in the sense which is going to protect us from the harmful rays of the sun. So this is very much important for us to be protected from the hot sun rays. Clear children? And now today we are going to learn about composition of air. Composition of air in the sense like what are all the ingredients, okay, which are available in the air. Okay children, so all of us are aware that air is a mixture of gases. Air is nothing but a gas. No, so it has got so many gases in it. It is not of only one gas like only oxygen. No, so it has got oxygen, carbon dioxide, nitrogen, like that. So many gases are available in the air. So that is why we say that air is a mixture of gases. Okay, it mainly consists of nitrogen, that is of 78%, oxygen of 21%, and other components such as carbon dioxide and other gases of 1%. Okay children, so this is the ratio of the gases, like how much of quantity of a particular gas is in the air. For example, here nitrogen is of 78%. If you see children, so this is in the maximum number. No, in 100% of air, 78% of air is occupied with nitrogen. Okay, and oxygen is how much? It is of 21%. Okay, and the other components such as carbon dioxide and some other gases, okay, they are only of 1%. Only 1%, that is the very minimum quantity. Okay children, clear? So nitrogen is of 78%, oxygen is of 21%, and carbon dioxide and the other gases together are of 1% only. Along with the air, air also contains along with the gases, it also contains small quantities of water vapor, dust and smoke. Okay children, so what does it contain? Apart from gases, you also have water vapor, dust and smoke. So these are the composition of air, in the sense they are the ingredients. For example, if we want to prepare tea, what we will use? We'll use is a mixture of tea, is a mixture of milk, sugar, tea powder, water, all that. No, so then it becomes the tea. Here air also, it contains so many gases like nitrogen, oxygen, carbon dioxide and so many. Okay children, if you see here in the picture, you have got a pie diagram. Now this is a pie diagram. See, like nitrogen, it is marked with the yellow color. So maximum quantity of air, it is with nitrogen, which is in yellow color. This one, this is nitrogen. Okay, and the green area is of what? Is of oxygen. This is of oxygen. And the red area, so what is that? So red area is nothing but argon and carbon dioxide and other rare gases. So very minimum ratio, that is only 1%. Okay children, clear? So now you are clear about what you are having in the air. Let's learn about these gases in detail. So nitrogen, here it is about nitrogen. So nitrogen is the most abundant gas in the atmosphere. Okay, so most abundant is nothing but which is available in large quantities, plenty of. Okay, as we said, 78% is available. That is, the large quantity of gas is available in the atmosphere. Which is that? That is nitrogen. Okay, living things require nitrogen, but it cannot be taken directly from the air. Okay, plants get nitrogen with the help of bacteria present in the soil. So, living things, who all come under living things, children? Animals, no, birds, like human beings. Human beings are also under animals only, okay? And even plants, these are all living organisms. So, all living things require nitrogen. They require nitrogen, but we cannot take it directly from the air as we take oxygen. So same like that, we cannot take nitrogen directly from the air. Okay, so plants, they get nitrogen with the help of bacteria which is present in the soil. So plants also need nitrogen to have a good growth, in the sense to have a strong growth. So to give us fruits, flowers, food and all that, plants require nitrogen. And how do they get this nitrogen? They get the nitrogen with the help of the bacteria which is present in the soil. No, because plants are in the soil. No, so again in the soil bacteria is available. So with this bacteria, plants are going to get the nitrogen. So what happens is, these bacteria fix the atmospheric nitrogen to different forms that can be taken up by the plants. So this bacteria, what does it do? It is going to make this nitrogen, the atmospheric nitrogen, in the sense which is available in the air. That nitrogen, that particular form is changed into different forms. Okay, so like it changes into gas form or some other form. So which can be taken up by the plant. As we said, we cannot take the nitrogen directly. So the bacteria which is available in the soil, it is going to change the nitrogen in different forms so that the plants can absorb the nitrogen. Okay, and when plants absorb nitrogen, what happens? They are going to give us a good crop. Crop in the sense anything, whether it may be a vegetable, it may be a fruit, it may be flower, so whatever it is, okay, it gives us a good crop. Okay, nitrogen is also added to the soil by means of fertilizers. See children, you might have been aware of this. Suppose if you are having any house plants at your home, so sometimes we give fertilizers to the plant. No, because to give them the strength to give us a good yield, that is good crop. No, so we'll add some fertilizers, some chemical fertilizers which we buy from the market and come, or else we'll make the own fertilizer at home. Like if you say banana peels, onion peels and all these vegetable peels, so that are all we are going to make a compost and give it to the plants. Why? So we want the plant to get the nitrogen, because it is very much important for the plant to grow. No, so you might have asked your mother specially, like who is taking care of the house plants, that how do they give the fertilizers to the plant. Okay children, so this is how we give our fertilizers for the plant. And human beings and animals get nitrogen from the plant and animal sources of food. Then how we are going to get, that is human beings and animals, how these living things get the nitrogen? So we are going to eat food of the plant and the animal. No, plant food like vegetables, fruits, green leaves, all that we are going to have as our food. Even animals also eat plants and all that. No, so this nitrogen is absorbed from that food. No, our body is going to take nitrogen from the plant food and the animal food. Okay children, so because they take nitrogen from the soil and we are going to take nitrogen from them. Clear? So this is about nitrogen. Okay children. Now we'll learn about oxygen. So oxygen, so it is very much necessary for the survival of living things. So oxygen, without oxygen we cannot breathe. No, if we are not having oxygen, in the sense, so we are not able to live. Okay, so all living things need oxygen to breathe. Oxygen is also needed for burning. So not only for breathing children, like we breathe air, that is the oxygen, even oxygen is also needed for burning. Burning in the sense what? Like fire. Even fire also requires oxygen to burn. Okay, because oxygen is going to support the chemical process that occur during the fire. No, so to a burning, that is the fire burning, is also a chemical process. So during that process, oxygen is going to support the fire to burn. Okay children, this we can learn through an experiment. I'll tell you later that. Okay. Now green plants give out oxygen during the process of photosynthesis. So green plants. Now green plants are what plants children? They are the self-making food plants. They make their own food. No, through the process of what? Through the process of photosynthesis. No, so in this process, when green plants are making photosynthesis, then they are going to release oxygen. They are going to give out the oxygen. Okay, so even by this also oxygen is generated. Okay, so green plants give out oxygen during the process of photosynthesis, and this oxygen is very much necessary for all the living beings for their survival, to being alive. Clear children? Now we learn about carbon dioxide and other gases. So carbon dioxide is released into the atmosphere during breathing and burning. So we'll take air inside and we'll release air outside. In the sense, we'll breathe in and breathe out. No, we'll breathe in the oxygen and we'll breathe out the carbon dioxide. Yes or no? So same like here, carbon dioxide is released in the atmosphere. So that is how we say that it is released in the atmosphere during breathing and also burning. So when it is burning, even when the fire is burning, carbon dioxide is released. Okay children, so that is why we say that this gas is released during breathing and burning. Plants use carbon dioxide for the process of photosynthesis. See, plants, what do? They'll breathe in the carbon dioxide and breathe out the oxygen. So it is like reverse. Like we breathe in the oxygen. We, in the sense human beings and animals, what we do? We breathe in the oxygen and breathe out the carbon dioxide. In the sense when we inhale out, then carbon dioxide will be released. But for plants, what do? So they are going to take carbon dioxide and they are going to release the oxygen. And when do they take carbon dioxide? In the process of photosynthesis. Plants use carbon dioxide. They are going to use carbon dioxide in the process of photosynthesis. And other gases such as helium, neon, hydrogen, argon, krypton and ozone are also present in the air. So we learnt when we were starting this session that so carbon dioxide and other gases, they consume about 1% of atmosphere. Now what are the other gases? These are all the other gases which are present in the air, like helium, neon, hydrogen, argon, krypton and ozone. Clear children? So but the main gases what we need is like nitrogen, oxygen and carbon dioxide. Now what are water vapor, dust and smoke? So these are also the part of the air. No, even air contains this also. water vapor, dust and smoke. So air also contains a small amount of water vapor, dust and smoke. Heat from the sun causes water to evaporate from the surface of seas, oceans, lakes, etc. So you might have learnt about the water cycle in your previous classes, children. So if not, so we can observe that when so much of heat is generated in the atmosphere, what happens? The water bodies such as seas, oceans and lakes, they get heated. Now the water becomes hot. When the water becomes hot, what will happen? Water starts evaporating. You can see, no, even in our kitchen or on our heaters. So when water is going to boil, it's getting so much of heat. So you can see some of the water vapor. No, even in the form of smoke also. No, this is nothing but the water vapor which is evaporated from the heat. Okay, so like this water vapor is generated in the air. Okay, and the amount of water present in the air is called humidity. So the water, that is the water vapor which is generated from the heat of the sun, okay, through the water bodies. No, and this water which is present in air, it is called as humidity. What is humidity, children? The amount of water, amount in the sense the quantity of water which is present in the air is called humidity. It plays an important role in determining the daily weather. No, even in the previous session also I was telling you. So some days we feel very heat. No, we feel very heat. So when it is so much of heat in the climate or in the weather, so what happens? Rain starts. I mean, it occurs for a rain. This leads for a rain. So why? Because after this heat, so much of heat, the water bodies are going to get much heated. This water is going to evaporate and it is going to reach the sky. Clouds will be formed and then what happens? Rain is going to occur. So this is the process of a water cycle, sorry. So we'll be learning this more in detail in your coming lessons, children. So that is why we say that this water vapor, dust and smoke are going to play an important role in determining the daily weather. So we'll have rain, we'll have sun, we'll have heat and all this. Okay. So clear, children? Now, so we'll be learning about some activities. No, activities. What is this? To show that oxygen is necessary for burning. So we have just learnt before that oxygen is very much necessary for burning. Let us learn through an experiment here. So try to do this at your home, children, but please do it under the supervision of your parents. Okay, so don't do it alone. Take your elders' help in doing this experiment. Clear? So that you will get a clear idea of this process. Now what you need is 2 candles and a glass jar. What you need is 2 candles and a gas jar. So first thing is you have to place the candles on a table and you have to light them. Okay. After a while you have to invert the glass jar over one of the candles. In the sense you have to just cover it. So you have to invert in the sense you have to cover a glass jar over one of the candles. Okay, so that air is not going to enter into that particular jar. So as you can see here in the picture. See, so you have taken 2 candles, you have lit the candles, 2 candles, and for one candle you have just closed, no, by inverting a glass jar. Please take a glass jar because you cannot take any other container like a plastic container, it's going to burn. So if you have a glass jar, take this and just invert it. Now what happens? After some time the candle that is exposed to air continues to burn, whereas the candle covered by jar burns for a short while and then stops burning. See here, children, So which is open, it is going to burn, but which is closed with the jar, that it is not going to burn for a long time. Only for some time it burns and then it will stop burning. No. So why is this? Why is this happened? Okay. So as we learnt that the flame of the candle in the jar goes off because covering the candle cuts off the oxygen supply. So the flame of the candle, no, when it lights, when it's burnt, so the flame will come from the candle. No, the flame of the candle in the jar, it's going to goes off because when you are covered, you are covering the candle, it is going to cut off the oxygen supply. There is no scope for the oxygen there. No, so oxygen is not able to generate in that particular place. So that is why that fire is going to be what? It's going to be closed. It's going to be stopped. Okay. So conclusion is, this shows that oxygen is essential for burning. So that is why we said that oxygen is very important for burning. Okay children. So please try to do this activity in the supervision of your parents or your elder brothers, sisters, whoever at home. Okay children. Now air is used in burning, breathing, and also in a process called rusting. So we learnt about burning, we learnt about breathing, and we learnt that air is very important for these two. But not only this, air is also used in one more process, that is in rusting. So objects made of iron get covered with a reddish brown substance called rust. So have you observed children, some of iron objects which are in our home, okay, which we are not using, so we are just keeping it outside or in somewhere in the storerooms. So sometimes we see it with a reddish brown substance. So we see them in a dark red color substance which is covered for this particular iron object. So that is called as rust. We call it, that particular substance, as rust. Okay. So this happens when iron objects come in contact with air and the water vapor present in the air. So how does this rust occur to that particular iron is, so this, when the air, when it is kept open somewhere, so when the air and the water vapor which is present in the air, the air and the water vapor which is present in the air is going to come in contact with that particular iron object, then this rust is going to be covered to that particular object. Okay children, clear? So air is also used, air and water vapor is also used in this process like rusting. Rusting is nothing but which is covered, which in the sense here, an iron object which is covered with air and water vapor. Clear children? Now we'll just learn about the properties of air. So we know that air has weight and it occupies space. Let us do some simple activities to understand these properties of air. So we all know that air has weight. Air has weight and it also occupies space. It needs space and it also has weight. So we'll just learn this by doing some activities children here. And this is the second activity in this chapter for you. Here is like we want to show that air has weight. Okay, so what do we need? We need two balloons and we need a needle. We need 2 pieces of thread and a scale. See here, there is a scale children. So we have tied this scale. In this sense, we have just tied this scale here to any object here, and we have just tied 2 balloons to the either end side of the ends, like in this end one balloon and the other end other balloon. So have you seen this clearly? Okay, now what we have to do? We have to blow air into both the balloons. So we have to blow air in both the balloons, and the second step is we have to tie the balloons with the help of threads to either side of the scale. First thing is you have to blow the balloons, and you have to tie the balloons with the help of threads as we have seen in the picture. Okay, now what we have to do? We have to lift the scale. Lift the scale, and we have to observe how the scale is positioned. Now when you tie both the balloons, children, so when you tie both the balloons, that is which are filled with air, both the balloons, and when you lift the scale, first you observe the position of the scale, like how it is. Okay, how it is, first you observe that. Then what you do? Now burst one of the balloons. Now burst the fourth step here. Burst one of the balloons with a needle. Okay, so now what you do is, after lifting it, then burst one balloon. Burst one balloon, then you just see what happens. Now this balloon is burst, and this is again filled with air. It is same as it is. Okay, now observe what happens. So what happens is, on lifting the scale, it stays horizontal, but when one of the balloons is burst, the scale tilts towards the balloon that is still intact. Okay, what happens is, children, so first when you place both the balloons with equally filled air, so it stays horizontal, in the sense it stays horizontal. Okay, like it's in this shape. Now this is the scale with the balloons. It is in the horizontal position when both are filled. So after we have burst one particular balloon, what happens? It's going to tilt, in the sense it's just going to bend towards the other balloon, which is with air. Okay, so this is the tilting position. Okay, clear, children? Oh, this is what happens. Okay, and it is towards the balloon which is still in fact intact, in the sense which is still having the air inside it. So reason is, this happens because the intact balloon has air inside it, which makes it heavier. What we learned? That air has weight. So this proves that this balloon which is filled is having weight and it is heavier. That is why the scale is tilted towards this particular balloon. Okay, children, clear? Now, so this, what is the conclusion? This shows that air has weight. Okay, so please try to do this activity, children, so that you will have a clear picture of these type of scientific things, experiments. Okay, children, and now we'll do one more activity. And in this activity we are going to say or show that air occupies space. Air occupies space, and what you need is balloon. So most of our experiments are with balloons only. So it's very easy for you to perform this task. Okay, so what is the procedure? Hold the balloon in your mouth and blow into it. So this is a very easy and interested task for us, blowing the balloons. No, so hold the balloon and just blow it and observe what happens. What happens? The balloon increases in sizes when you blow into it. When you keep in your mouth and you blow the air into the balloon is going to increase the size, increase its size. No? Yes or no, children? Yes. So why is this, children? Reason is, the air we blow into the balloon occupies space, hence the balloon increases in size. So whatever air we are going to blow into the balloon, it is going to occupy the space inside it. So that is why the balloon is increasing in its size. Okay, and what is the conclusion? This shows that air occupies space. Clear, children? Even cycle pump also. tires also. We'll just, when we blow air into the cycle tire, no, it just increases the size. In the sense, air occupies space. Clear? And because of its weight, air pushes everything around it in all the directions. In other words, we say that air exerts pressure. This pressure is called the air pressure. Okay, children? So because of its weight, so as we said, air is having weight. Because of its weight, it is going to push everything around it, which around it in the sense wherever we are blowing the air. Okay, and it is going to push the air into all the directions. Okay, so this is like that is, air is exerting the pressure. In the sense, it is producing the pressure, and this is called as air pressure. Okay, children? So let us do a simple activity to show that air exerts pressure. So there is one more activity, children, where we are telling that air exerts pressure. This is the fourth activity for you. So what you need is plastic cup and index card. In the sense, any cardboard, like a piece of cardboard, you can cut it, children. And so it is better for you to try this over a sink. No, every house we have got a sink. No, so it's better because this is an experiment where water is included. So it is better we do it in our sink or in our wash areas. Okay, children? So what is the procedure? Fill the plastic cup with the water. First, take a plastic cup and fill it with water and place the index card on the top of the cup. Now, this is just like a magic for you. So fill the cup with plastic cup with the water and then place the index card. In this is the cardboard. Okay, small cardboard in the top of the cover. On the top of the cup. Like just cover it with that. Okay, children? Now what you do? See here. So this is the water. You have half filled the water actually. This is the cup and you have half filled the water, and you have just closed this with the cardboard, the cup. Okay, and now you are going to hold the index card tightly against the mouth of the plastic cup and turn the cup upside down. So what you have to do, children, you have to reverse the cup as it is there in the picture. You have to just reverse the cup by holding tightly the cardboard. Okay, just slowly try to reverse the cup. What happens is, carefully remove your hand holding the index card in place. Now what you do? So because now you are holding the your hand on the cardboard, and you are just reversing it. Now slowly you just remove your hand. You just slowly remove your hand holding this card. Okay, and what happens? The index card does not fall. We feel that the card is going to fall down. At the same time, even the water also will come out of the cup. But this is like a magic for you. The index card, it does not fall. It is not going to fall down. So why is that? The pressure of air outside the plastic cup is pushing the card up. So we are having air, outside the cup we are having air, and this air, because of its pressure, this air pressure which is outside, it is going to push the push the card towards the plastic cup. Okay, children, so this is what is called as air exerts pressure on objects. So this shows that air exerts pressure on objects. Clear? So children, please try to do all these activities at your home. Okay. Now just upwards, air exerts pressure on all sides. When a balloon is blown over its maximum size, the air pressure increases. So at some point, the air exerts too much pressure on the walls of the balloon and it bursts. So children, sometimes what happens, as we learned that air is going to exert pressure on all sides, not only upward and the all sides. Now sometimes we blow the balloon to its maximum size. No, we'll just blow it and it becomes big and big and big. No, but as we blow more air, what happens? It is going to burst. No, sometimes we also hang them to the walls or to any corners for decorative purpose. So we'll observe, so suddenly they are bursting even without touching, without pointing anything towards to the balloon also, they are bursting. Why? Because the air exerts too much pressure. The air exerts too much pressures on the walls of the balloons and it is going to burst. Okay children, so this is how we learn that air exerts pressure on the all sides. And we are also having some more applications which are in our daily life. So to know about the air pressure, okay, see here, like drinking through a straw. Drinking through a straw. Now we are drinking the water or anything. So this is also because of the air. So it's going through the whatever liquid is there, it is going towards through the straw. No, to upward direction. So this is because of the air pressure, children. And not only this, filling up injection syringes. No, we'll fill the injection syringes. No, with the medicine, the liquid type of medicine. This is also because of air pressure. Even getting water from a heart pump. No, when we just pump the hand pump, we'll get water. So this is also of air pressure. So using a vacuum cleaner. Okay, so all this working of airplanes and sailboats. Okay, this is sailboats, children. SAIL, sailboats. Okay, so how do aeroplanes and the sailboats work, children? Because of the air pressure. Now as the air pressure goes, even they change their directions. Okay, clear children? So this is what we have learnt about the air pressure, and we'll be going to learn about water. Okay children? So hope you have understood about the composition of atmosphere and the properties of air, children. So we'll be concluding here. We'll be going to continue in tomorrow's session. Until then, stay well, take care and goodbye. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.